Hi all, this video will be discussing the answers for lesson 7 of chapter 4, which is about the CPC-TC theorem, which if you would have watched the explanation video, you would have understood it's a much easier theorem than, it's a much easier part than the ones which we were learning. So let's start this part quickly. It has only 3 questions. So this question, they did not ask for a proof, they did not say anything, it needs explanation. Okay, now I'm explaining from my part, but it's totally up to you how you are going to write it, because I cannot say that's the correct way to write, but the idea needs to be the same, right? So the question says, Heike Dressler set the women's world junior record for the long jump in 1983. She jumped about 23.4 feet. So she has jumped about 23.4 feet. The diagram shows 2 triangles and a pond. So you can see that there is a pond here, and then there are 2 triangles. Explain whether Heike could have jumped the pond along path BA. So could she jump along path BA or along path CA? So you have to choose whether she jumped around to 23.4. So you need to decide whether she jumped along BA or she jumped along CA. Now to find that, first of all, we need to prove that the 2 triangles are congruent, right? So we could say that as C is the midpoint, you can see that C is the midpoint. You could say that CD is congruent to BC, CB, and then 2 angles are congruent. Also, you could say that these angles are congruent as well. That's due to you can say that is side angle theorem, right? So due to ASA, you can say that the 2 triangles are congruent. So this, I'm just giving you the idea. You need to write it in your own words, okay? So once you have proven that 2 triangles are congruent, now remaining definitely are going to be congruent due to CPCTC, right? Now, from CPCTC, we could say that DE is 20, so AB is also 20. CE is 25, CA is also 25. So if BA is 20, CA is 25, which way do you think she would have jumped if she jumped around 23.4? Will she choose, has she jumped over CA or BA? It's going to be BA because BA is 20, right? So 23.5 is a bit more than 20, but this is 25. So she cannot, like, if she would have jumped beyond that, that's going to be more than 25. So the correct choice is going to be BA. So here I'm just going to type the explanation. Now again, it's not necessary that you need to do the same as mine. You can explain in your own words if you have understood that you have to first prove the 2 triangles are equal. Then you could say that the remaining parts are congruent as well. So because the triangles are congruent, how are they congruent? Congruent by ASA, because already I explained you why it is ASA, because these 2 triangles are congruent. This is congruent to this because of the midpoint. C acts as a midpoint, so both of them are 15. So these 2 are congruent, and by our knowledge, we could say that this angle C is congruent to this angle C because of the vertical angles theorem. So it is the 2 triangles are congruent due to ASA. So each side of, now I cannot draw a triangle here, so I'm just writing triangle ABC. Now these are my own words, up to you how you want to write. Has the same length as its corresponding sides. Corresponding sides in, okay, sides in triangle. Which is the other triangle? ABC. This is going to be EDC. It's a triangle EDC, right? This is due to CPCTC, because if once you prove that 2 triangles are congruent, the remaining parts are congruent as well. So how much did she jump? Now you need to mention. Now already we said in a sentence that the two triangles are equal, right? So I hope you could understand this because the triangles are congruent by ASA. Each side of triangle ABC has the same length as its corresponding side in triangle EDC. Now, as she has jumped 23.4, so the distance along which one they said is 20, BA is 20 feet, right? Is it feet? Yes. So the distance along BA is 20 feet. Therefore, am I making so many spelling mistakes? Therefore, who's this woman? Okay, could have jumped along BA, right? As the distance along the other one, CA, AC. CA is 25 feet, which she couldn't have jumped. So these are my words, okay? So up to you how you are explaining it, but the idea needs to be same. Like what did she jump? Definitely she would have jumped along BA. Okay. So moving to the next question, write a flow chart proof. You need to draw a flow chart. So to draw a flow chart, know what we need, right? We need ovals. So starting with the first one here. Let me draw that here. Okay. Okay. So what's the first thing I'm going to write here? The first thing I'm going to write here is saying the given proof. So what's the given proof here already? Angle L is congruent to angle J. L is congruent to J, and KJ is congruent to LM. Sorry, they're parallel to LM, right? So first let's start with this line so that we could prove the remaining parts later on. So we can say KJ is parallel to LM, which is given. Okay, then now because of this given thing, what happens is, so we need to draw an arrow. Okay, so because of this, what has happened? It's a big task to draw these figures. Okay, so now we are gonna, they talked about KJLM, so that we can say now K, this angle K and angle M. That angle LMK and MK is congruent to angle JKM, right? We could say this. So these two are congruent. So let's write that down here. Angle L and K is congruent to angle JKM. Now this is due to alternate interior angles theorem. Okay. Now what other information is given? The other information which is given is L, the angle L is congruent to angle J. So let me write that down too. Angle L is congruent to angle J. This is also given. Now we already know two angles, right? We know that this angle is congruent to this. We also know that this angle is congruent to this. So what else can we find out from this figure? Again, we can say that Km is congruent to Km, right? So I'm drawing another arrow. I'll draw this here too. So I could say that this is going to be Km is corresponding to Km because of the reflexive property. Where did I write it? Congruent to Km because of the reflexive property of congruence, right? Now, where does this all three things lead to? So already um, we have one angle, that's this and we have already this angle too, and already we have proved this. So keeping all these three things in mind, which theorem do you think we're going to use here? Think of this thing. So this one, and in fact, this is not needed. This line is not needed because it's not related to it at all. So from here, in fact, I should have drawn that there, but where does all these three things lead to? Which theorem did we use right? Are we using now? You know that well. We're using AAS angle side. So just let me write down. Because of all these three things, we can say now triangle LKM is congruent to triangle JMK from which theorem? AAS theorem, right? Now again, because of that is AAS, so can I say now the remaining parts of the triangles are equal to? Yes, we can. So just draw another circle, place it properly. Hopefully it's more easier for you rather than dragging and writing. So angle LKM is congruent to angle JMK because of CPC, TC. So first, use any theorem to prove that the two triangles are congruent. Then finally say that LKM is congruent to JMK because of CPC, TC. Now the order of these doesn't matter. Not necessarily you need to draw these circles like me. You can even draw them underneath each other. But then the arrows lead should be together. Like because of this, we found out that these two angles are equal, right? Now this is a given proof. So the given one will directly lead to the congruence equal triangle equality. This we found. So all the three things, that's side, angle, side. So that's why the triangles are congruent. Okay, let's do this one. FGHI is a rectangle. Prove the diagonals of the rectangle have equal lengths. So we need to prove this is equal to this. Okay, so they want you to draw a two-column proof. Let me draw it first. Okay, so this is the two-column proof. Okay, so here we are going to write the statement and here we are going to write the reason. Now, yes, you need to draw it more neatly than what I have done here. It's not correct, but fine. For us, the proof is important. So always we start by writing the given information. The given information is FGHI is a rectangle. So we write FGHI is a rectangle. That's because it is given. Okay, now what information can we derive because it's a rectangle? Now keep in mind in rectangle, the two opposite sides are equal and all the angles are right angles also. So we just have to prove that IG is congruent to FH. This is what we are going to prove because they said the diagonals have equal lengths. So we are going to prove that. So the next thing we are going to find out from this rectangle is you can see that FI is congruent to GH as well if G is congruent to IH. Just now I told you that they are the opposite sides of us. Rectangles are congruent, right? So we can say that Fi is congruent to GH, right? Also we can say that FG is also congruent to HI. FG is congruent to IH. We have to follow the order.
Now, why did we say that they both are congruent? What reason do you think we are going to give? That's, you just write it as definition of rectangle. Because it's a rectangle, the two opposite sides are congruent, right? So definition of rectangle, simple. Now it's not, that doesn't mean you can find your own theorems, okay? You cannot write anything and say definition of the line, definition of this. You cannot do that. But why did we say that if I is congruent to GH? You can say that they both are opposite sides. We also said FG is congruent to IH because they're also opposite sides. So that's the definition of a rectangle. The two opposite sides are congruent. Opposite sides are equal. Okay, so what else can we find out from this? We can also say that angle I and angle H are right angles. That's also because of the definition of rectangle. So let's write angle I is congruent to angle H. That's also due to right angles theorem. Right angles theorem. Okay. Now I have proved that angle I and angle H are congruent, right? And also I have proved that if I is congruent to GH. Now the next step is going to be, you're going to write IH. Already we have written here. IH is congruent to, okay. So because we are finding, we have to prove that these two lines are congruent to each other, right? They both are equal. So we are talking about this triangle and this triangle. So from this triangle, we could say that IH is also equal to IH. Now you could give that as reflexive property. You know, if something is equal to each other, that means they both are, that's due to reflexive property. So let me write here as IH, sorry, or yeah, IH is congruent to IH. That's because of reflexive property of congruence. So now I could say that triangle FIH, that is FIH, is congruent to triangle GHI. Now what theorem did we use? We have used this side, we already said FI. Then again we said this angle, and now we also said IH is equal to IH because of the reflexive property. So which theorem did we use now? We used side, angle, and side, right? Now I can say that FH is congruent to GI because of what? CPCTC. Then finally you can say FH, that FH is also congruent to GI because of the definition of congruent segments, which means they both have equal length. So this is how you need to prove. Now quickly let me recap what is done here. You have to prove that triangle FIH is congruent to triangle FGH because they're saying prove that this line is equal to this. FH and FH is equal to IG. That's what they have said, the diagonals of the rectangle. So we need to prove that this side is equal to this side. So to prove that this side is equal to this side, we are talking about this triangle, right? And then we are talking about this triangle. So you could choose any two sides and an angle to prove that they both are congruent. And then finally you can say FH is congruent to IG, which means GI or IG, which means both of them have the same length. So that was all the homework for this lesson. Hopefully you have understood. It's nothing big because it's all related to the previous lesson. So till we meet again in the next video for the lesson, try to do some practice.